In the previous episode, we saw how to use heat set inserts, but we also looked at using the mirror tool to replicate features. This time, we'll examine similar linear and polar array tools to make designing patterns easier. We'll also talk about using Boolean operations to add and subtract parts. We'll design a custom servo horn that you can attach to a micro servo motor, and I want to connect to what's likely the most popular mechanical prototyping material of all time. It's essentially a disk with holes, but it should be good practice for making feature arrays and Boolean operations. Hopefully, you've gotten more comfortable with creating sketches and features in the part design workbench. We're going to look at two very common features in most CAD programs: array patterns and Boolean operations. These will make creating copies and mating parts much easier. Let's get started. I've already taken the measurements of the LEGO parts. We'll be mimicking this Technic belt wheel, but turning it into a servo shaft attachment. The holes are 4.8 millimeters in diameter and about 8 millimeters apart. To use these 3/4 pins, we'll need to make the disc about 2.3 millimeters thick. Before we get started, I'd like to make a note about the Involute gear tool if you want to make something to connect to gears or motors or create a gearing system. So in FreeCAD, if you create a new document, let's create a body here, you can go to part design and you can create an Involute gear. And that just walks you through the process of creating teeth for a gearing mechanism, and you can adjust the number of teeth. So I could have 18 teeth, and you could adjust various properties of it, and it essentially creates a sketch for you. I don't know how editable these individual pieces are, but this allows you to create something that you can then work with. Say, for example, I'm going to click on this and pat it, and now I have an actual gear to work with. I could also invert this to make something that attaches to my servos, which is incredibly useful, but rather than doing this, let's import an actual servo that we find on the internet and use the shaft as the basis for creating our servo horn. So I'm going to go ahead and cancel. I'm going to delete this body, and I'm going to close this document. Discard. We'll download a CAD model to start with, like we did in a previous episode. This time, we want to make a custom servo horn, so let's start with a servo motor model. I found this model on GrabCAD, so we'll download it and unzip it on our computer. In FreeCAD, make sure you're in the Part Design workbench. Click to create a new document, go to File, Import, go into that servo motor folder that we downloaded and unzipped, find the .step file, open that, keep the settings as their default, and click OK. In a moment, you should be presented with a nice servo motor. In my case, I'm using one of those little micro servo motors. If you have a different one, feel free to find a different model. What we care about is this shaft right here. So if I click on some line in there, it'll highlight that shaft for me in the tree view. I can click on that and you can see that shaft show up. That's all we care about. We can actually delete everything else in this servo model. What I'm going to do is actually right click. I'm going to copy that shaft. I'm going to collapse the servo motor model. I'm going to go to edit and paste. That keeps just the shaft. Now I'm going to right click and delete the original servo. Yes, that's fine, delete everything, and I should be left with just the shaft as a body. There are a number of things you can do with this. If you want to put this into a body, you can create a new body out of that, and it looks like it auto-imported for me. So if I delete this base feature, see I've got a body there, I can actually drag this in here, and it creates a new base feature. Now this acts as its own body. When I say body, I mean a body as part of the part design workbench, as opposed to a part that's over here. You can see it's a little better aligned on those axes. I can delete that. I can also click on this. I can create a clone, and that creates a clone that is now linked to this original part. So if I try to delete this, it's going to say, oh, this is linked, and if I delete the original, it's going to break the clone. Once again, this acts as a body. And there's a number of things we can do with this. These are parts, and we can use Boolean operations in order to combine and subtract them with other bodies. So what I'm going to do right now is I'm going to delete this body. So we just have this original part. I'm going to use a subshape binder to construct most of the wheel we want to use as a servo horn. And then I'm going to demonstrate how to use the Boolean operation to subtract this shaft from that part to create this nice cutout with this gear pattern in it. So make sure nothing's selected, create body, select that shaft, click subshape binder. Now we have a reference that we can use. I'm going to go ahead and hide the original shaft. If we view the original axes, you can see this is rotated, and we can see that this is rotated all around here. Okay. To fix this, click on the original body, go under placement in the properties. Let's adjust these axes. So let's change this angle to 90. We'll change X to 1.00. This acts as a vector, so you can see with 101, it's now pointing off in the direction here because it's saying, oh, 1 times 90 degrees, and then 1 times 90 degrees in the X and Z axes gives us that angle. So we want nothing in the Z axis. That should ideally rotate it so it's pointing up in that Z axis. Okay, so that looks good. Let's go to position. This is offset from our origin. So let's change all of these to 0 to get it something closer. And that doesn't put it right on the origin, but it's close enough. So we at least know that it's 0 and that binder should follow along with it. So now we're good to go ahead and start creating our custom horn. To demonstrate how to attach sketches if you sketch them on the wrong thing, let's create our sketch on the XY plane. So I'll select that, click create sketch. I'm going to bring in one of these inner circle edges, and I'm going to bring in this piece of this tooth, this gear tooth here. Right click to exit that tool. Now if I view section to slice that camera, I should have this semicircle around what I believe is the x-axis here, and this piece of the tooth that we're going to use as a reference point. First thing I'm going to do is click to create a circle. I want to create it out from this hole here. I'm going to make it bigger than where those gear teeth are. Right click, notice that the circle is based around that center point of that gear. So let's view section. So you can see we're going to create a pad that's going to cover that shaft for us. And we want to make it 2 millimeters bigger than this point. Now, I can't quite make it horizontal here. That's not quite how that works. So if you ever want to create a circle and make it concentric and larger than another circle, or in this case, pattern like this, what I like to do is use reference geometry. So click on this, or construction geometry. It's going to turn all of your geometry blue, which creates construction geometry, and it's reference lines and circles that don't get exported with that sketch. Instead, it just allows us to create sketches based on it. So I'm going to click this center point. Then I'm going to click somewhere on the outer edge so that these are connected now. So now the circle is controlled by this radius. I'm going to click my constrain coincident. I'm going to click on this line and this point. So even though this is not horizontal, I can now set a distance between these 2 points, and it will set that circle for us. So click on the Smart Distance tool, click this point and that point, and you notice it's trying to create a horizontal distance for us, depending on where I try to move this tool. So if this is a pain in the butt, you can exit this tool, and instead of using that horizontal distance, we can do constrain distance to force that. So I'm going to click on that point and that point. Now I'm going to make this 2 millimeters wider than the extent of these teeth. Right click to exit that tool, and now we have a fully constrained sketch, so exit out of that. I'm going to hide my origin axes, and you notice this sketch is not really related to this shaft. We want to change the attachment mode, so click on sketch, and you can see the attachment mode in the properties as the XY plane. So click that, click the 3 dots, and what we want to do is we want to click the top of this shaft, which you notice if I highlight it, turns out like slightly greener color. So I want to click there. If I say OK, you'll notice that I have 2 things selected, and it's not quite sure what to do with that. So we want to get rid of that XY plane as one of the attachment points. So come in here, click on XY plane, and click OK. Now the sketch is actually attached to that top face of the subshape binder. You'll notice a little circle here, a blue circle, that's a sub icon with a white check mark in it. That means that this body needs to be recomputed. So to do that, press F5 on your keyboard. It will recompute, And looks like nothing actually changed here, but it makes that go away. So if you ever see that little blue icon, that means it needs to be recomputed, which just updates all of the features and goes through the math in that body in that sequential order, and that's just how part design works. Next, we want to cover a portion of this shaft. So click on that sketch. We're going to pad, but we actually want to go pad downward. So click reversed, and we're going to make this, I don't know, 2 millimeters. That sounds good. I don't know why that binder disappeared, so let's make that reappear, and we can see that pad go there. Now we're going to make our larger wheel here. So let's click this top face, click sketch. We're going to bring in this circle as external geometry. We need that center point. If you notice that these lines and circles, these tools are blue, that means you're doing construction mode. You should also see that happens if you ever create one and it's this dash blue line, that's construction geometry. That's not what we want right now. So let's get rid of that. We'll change over to regular geometry, click create a circle. We'll start with that center point, and we're going to come out some distance. Right click to end that tool, press D to use the smart dimension tool. Let's change this diameter to 24 millimeters. Right click to exit that tool, click close, and we are going to pad this by 1.5 millimeters, as that is the dimension measured from the Lego wheel. So now it's starting to look a little bit like a wheel. We need to create a screw hole here so we can mount it to that shaft. To do that, I'm going to bring in one of these holes as a external geometry, but first let's click on that top plate. Let's click create sketch. Let's rotate the camera around so we can see this. I'm going to click external geometry, and you can barely see this. Let's see if I can get it in here. This line should turn a slightly different color for me when I highlight it. I think it's right about there. If I rotate around, sure enough, I got it. So there's that dashed magenta line. Let's go to top. Oof, that's bad. There we go, much better. Right click to exit that tool. Let's create a circle that is exactly that size. Right click to end. We're fully constrained. Click close. And let's cut a pocket all the way through. So through all, click OK, and now we have that screw hole. Next, we want to add the holes for mounting the pegs. So let's click that top plate again, create sketch. I'm going to create some arbitrary circle over here. I could attach it to this x-axis, but rather than doing that, I'm going to show you how to align it with this circle here in case you don't have this nice x-axis that goes to the center of your circle. Let's bring in this circle as external geometry. Right click to end. Let's use the constrain horizontal, and we're going to constrain this point horizontally to this point. So now this can move horizontally, but not up and down. Then we're going to use the distance tool to constrain this hole to be, let's say, 8 millimeters, and that was measured from the Lego part. Right click to end, or we didn't actually need to end it. We need that dimension tool again, and we're going to make this 4.8 millimeters. Done. We are fully constrained. Click OK, and once again, let's pocket. Let's go through all, click OK. So now we have that first mounting hole for that peg, and we want to create a polar pattern. In a lot of cases, to make this easy, you would create a polar pattern around, say, this z-axis. That makes life easy, but that goes through somewhere else on our part. To create an arbitrary axis, we actually want to create something called a datum line. You also have datum planes to create, say, arbitrary sketches on, but a line will act as an arbitrary axis point that we can then create a polar pattern around. So let's hide these axes, and we need to place that line. So let's select datum line, which you can also find in part design, create a datum line. This just places it somewhere it seems randomly. I think it's on the axis, the z-axis. Yeah, that's what it looks like. It's on the z-axis. So that's where it places it by default. In the tasks, it wants us to attach it. Here it looks like it's attached to the origin. If I select this, sometimes this works and sometimes this doesn't. So I can actually attach it to this circle, which puts it in the middle. If I try to select, let's see if I do that. No, it puts it in the plane and it's not quite centered. So that's not what we want. So let's select, and we want to hit the edge. If we try to place it in the middle here, no, it doesn't like that face. You see, I get this error. So select it again. Let's click on this edge. There we go. That looks like the center of that circle. That looks perfect. So click OK, and now we have a datum line that goes to the center. Sometimes I find when trying to attach datum lines and datum planes, it's usually just playing with those attachment points to get them to attach correctly in the orientation that I want. So with that in mind, we want to make sure we have the pocket selected. If we just don't select anything and click the polar pattern, it's going to do the entire body up into that point. Not quite what we want. So click cancel, click the pocket in the tree view, and then click the polar pattern. That looks much better. It's probably trying to put it over here, which is not what we want. So in the tasks pane, come down here. We want the axis of rotation to not be normal sketch, not be the z-axis. We want to select the reference, zoom in, and select that datum line we added. And that's going to create a polar pattern around that. We only have 2 right now, so let's change this to 6. Press tab in order to update the view, which sometimes it does automatically and sometimes not. And that looks really good. Click OK, and we are done with that. It looks a lot like that Lego wheel. At this point, we are ready to try subtracting this part from this part to create a mounting hole for our shaft. And I'm going to put it back into view here. I find that you can't really do this Boolean cut with, say, the binder. You might be able to do it with this original piece. So if I click this and click the Boolean operation and I go to cut, let's hide this binder, you can see that it was cut pretty easily. That is fantastic. I love that that cut is super simple to do. You see it adds a feature in this body here. There is one slight problem, and that is if I need this complicated piece to be larger, or rather I want the cut to be a little bit larger so that it actually mates up nicely with that shaft, that is much more difficult to do in base FreeCAD without some extra add-ons. I am going to show you how to do it. It's just I consider it one of the weaker parts of FreeCAD because it's not very intuitive. So let's cancel that, get rid of that cut. Note that that works pretty much out of the box. I can't use the binder if I try to Boolean cut that. It just kind of fails and yells at me. I get this error, so cancel out of that. The first thing I want to do is I'm going to hide this body, and I want to make a clone of this part here, this shaft. It gives me something to work with that I can make a little bit bigger. I can use this clone, but that's going to put it in a separate body, and there is no easy way to scale that. That's another weak feature of FreeCAD, in my opinion, is scaling is not very easy. But I'm going to go to the draft workbench. I'm going to click on that original shaft that we copied out of that servo. There is a blue sheep clone, which is different than the orange sheep clone in the part design workbench, but I'm going to click that. And I'm going to, for now, hide this original shaft, click on this cloned shaft, and come down here in properties. Under scale, I can now adjust the size of this. So I can make this 2 times as big in the x-axis, and it does some weird stuff like that. With some math, I can probably figure out that, I don't know, a 1 or 2% increase gives me, a 0.1 millimeter gap around the edge, which makes it nice to fit in there. I'm going to guess 2% here. That seems to be good enough. Oops, I clicked tab there, so it went back to the top. But 2% increase in X, Y, and Z axes. There is a slight problem. Because we did not create this part along the origin, it actually scales everything out from the origin. So if I come here, you can see where that's been scaled. And let's make this a little bit easier. So I'm going to turn this off. And there you go. You can see how it's offset a little bit. That's going to be a problem with this. If I try to cut this, it's no longer centered on this part. What I should have done was create this scaled part first and then built the wheel on top of that. But let's say you're in this situation and you have created the part and now you need to cut and you want to scale the part you want to cut out, but you didn't build on top of that scaled part. That is a problem. But we can fix this using the alignment tool. Once again, very not intuitive feature, but it does get the job done, and I will show you how to use it. So I'm going to hide this. I'm going to head back to the part design workbench. I will be honest that I don't know the draft workbench very well, and I'm just used to part design a little more. I now have my 2 shafts. This is the original, and this is the scaled up copy that's shifted a little bit. What I'm going to do is click the part I want to move first, which is this cloned scaled copy. I'm going to hold Control and click some sort of reference. In this case, it's the original shaft. We're going to try to line these up. That order matters. Movable object first, the immovable object second. With those selected, I'm going to go to Edit, and I'm going to click the Alignment tool. This is almost like a separate workbench. And just to double check, ooh, this is backwards from what I have learned. This is why we check this. Notice that this is the movable object, and this is the fixed object. So let's try this again. So I'm going to exit, right-click and say Cancel. Let's try it again. Let's click the immovable object first, and we are going to click the movable object second. Go to Edit, Alignment, and now we double check, because this always bites me. So this is the immovable or the fixed object. When I click that, that is correct. And the movable object is the scaled clone. Perfect. I'm going to rotate both of these cameras. Let's go to the top, because what we're going to do is try to line up this hole to the top hole on this one. And I don't care if the Z is off. In fact, I want these two planes to be the same. What I really want is the X and Y to be scaled when I do that cut. So let's do the top view of this one, top view of this one. Let's make sure that they are oriented the same way. Then I'm going to click 2 points. So first, let me click off so none of these are selected. I'm going to find 2 points, and that's going to create the line that is going to provide the alignment. So there are 2 semicircles, and note that if you needed to, you could probably create sketches to make this happen. But for these parts, I have this point right here that I'm going to select, and then I'm going to select the point, the same point on the fixed object. So I'm going to click that point. Notice it marks it in red, 0.1, 0.1. Then I'm going to come down here and click this next point, so that's 0.2, and do the same for this one, 0.2. And this tool tries to be smart about how these line up. So I'm going to right-click, click Align, and now they should be aligned. Not the most intuitive tool, but it does get the job done. You can see that both of these are now aligned with each other. So if I remove that, they are lined up, and that Z plane is lined up, and that's good enough for what we need. Let's hide that original one, bring back the first one, and bring back the body. So now we've got a slightly bigger thing we can cut from. With the wheel as the active body, note the light purple highlighting on body here. We're going to select what we want to cut, and we are going to select the Boolean operation. It's going to default to fuse with the thing we're trying to cut here, but we're going to select Cut and click OK. Let's hide that binder, and you should see that that part was now cut. Because we made that mounting hole a little bit bigger, you'll notice that there's this cylinder we got to get rid of. And that should be actually good enough for what we need. I'm going to click on, let's see, I want to click on this plane. There we go, that's green. I'm going to create, nope, I don't want to click on that plane. I actually want to click on this plane in there. There we go. And then I'm going to create a sketch. Let's bring in this hole here. I'm going to create some arbitrary circle, set the dimensions. Doesn't really matter. Let's set it to 3 millimeters for the diameter. Right click, we are fully constrained. Let's exit. Let's do a pocket. That's going to punch it out that way, which is not what we want. Let's go reversed. And just to be safe, we can say through all and say OK. Now we have that mounting hole. That should be good enough for what we need. I'm going to add a chamfer just because it looks nice and it helps make connecting some of the Lego pieces easier, even if the printer is going to struggle with it. So let's do a chamfer. Let's select our edges. So I'm going to do all of these circles like this. I'm going to do all of the underside circles like this. I'm going to do this outer circle and this underside circle. Let's change this to something really small, like 0.3. And either you can click Tab or you can click Preview, and that should update the view like so. Once you're happy with this chamfer, we're going to click OK. And I think we're good to 3D print this. So select the body. Well, before we export, let's save as, and I'm going to save this as Servo wheel. Click Save. Sure, overwrite that. With the body selected, let's go to File, Export, Servo wheel body, Save. Yes, overwrite, and let's bring that into the slicer program. In my slicer, I will import that STL file. This part is quite small compared to what we've been designing before. I'll flip it so that it prints the flattest side down. So I'll use this tool here. I'll flip it 180 degrees. and make sure that part is blue, or click the lay flat button. That looks pretty good. Notice that the teeth show up here in the model, but when I click slice, they don't show up because they are far too small for a 3D printer. Well, let's print this and see if it still works. As this is a small part, the print should be pretty quick. Most FDM 3D printers have a little bit of squish when the plastic is extruded. Also, the axes aren't always very precise, at least not to the precision that LEGO components are made. You might need to use a small file or drill bit to clean out the holes for a good fit. If that doesn't work, you might need to adjust some of the dimensions in your model and reprint. With some luck, we can get everything to fit together. The servo shaft teeth should ideally bite into my 3D printed part, and we can secure it with the provided screw. A metal shaft would probably work better, but these are cheap servos. From there, I can add the Technic pins and then attach the beam. This opens up a new world of possibilities to control LEGO projects using basic servos. For your challenge, try designing your own servo horn or attachment. If you can, find some way to use the pattern and Boolean operations. Feel free to share your designs on X, Instagram, or LinkedIn with hashtag DKFreeCAD and tag DigiKey. This can be a screenshot or a photo of your 3D printed part. In the next episode, we'll look at extending our sketches to make interesting features through revolutions, lofts, and pipes. Stay tuned.